Really glad to see you all here today. My name's Howie Dickerman. I'm a senior program manager on the Excel product team. Prior to joining the Excel team this time around, I was also a program manager on the analysis services team, the team that became Power BI. So I'm familiar with this from a couple of different angles. In case I forget later, I've been primed. I say this out loud, I'll more likely remember it. As we get to the end and we're doing some Q&A type stuff, they would love, for the sake of the recording, if people could come up and use the microphone up front here, just because it gets on the recording that way for everybody. But it's going to be a few minutes before we get to that. So to start out here, the agenda for this session is that I'm going to talk about 5 different things within Power Pivot in Excel and Excel data models. They're listed here on the screen. We're going to talk about the data model as a database with multiple tables and relationships. We're going to talk about working with editable data. You know, the data model is generally a read-only copy of data that's been brought in from somewhere else, but it's interesting to have some data that you can edit and then rerun your model, rerun your calculations. So we'll show you how to do that. I'll talk a bit about DAX formulas, talk about custom calendars, and then spend some more time specifically on measures. This is not a full-blown course on DAX. That would take way more time, way more time. There are people teaching some DAX in various other sessions at the conference, but this will give you a good sort of high-level overview of some of these topics and how they relate to using data models and DAX formulas within Excel and Power Pivot. Basically, what I'm going to do is I've got about a slide or two on each of these topics, followed by a brief demo. So you're really going to see a bunch of demos of each of these things as we go along. So to start with, the data model, in Excel, we refer to this as the data model. It is a database that's stored inside the workbook. The editor for that database, the tool that you use to go in and add new stuff to that database and to change things in that database, is the Power Pivot add-in for Excel. This uses, the database engine here is actually the analysis services engine. Now, some of you may or may not be all that familiar with that. Let me just say that in the same way that when you buy Office, you get PowerPoint and Word and Excel. When you buy SQL Server, the overall product, you get not only the SQL Server relational database product, but you also get this database product called Analysis Services. And there are 2 flavors of Analysis Services. You can run it. For many years, it was run in multi-dimensional mode. People did multi-dimensional cubes, OLAP cubes. But more recently, we've got tabular data models and analysis services. So if you were using that product on a server, you would talk about analysis services in tabular mode. We use that exact same database engine in Excel, and we refer to them as Excel data models. The DAX formula language that we use is the same in both because it's really that same database engine. It is an in-memory column-based engine, which means we load the data model up into memory, and we can then do calculations on the fly. For example, with a pivot table, we can scan that data very quickly, go through a column, adding up a column of numbers, or getting min, max, average, whatever it may be, and do it on the fly in memory, again, using exactly the same technique as an analysis services because it's the same engine. In that data model, you have tables of data. We have relationships between the tables, and we have calculations. Those calculations might be in the form of calculated columns and might be in the form of measures. We'll be talking a lot more about both of those. This enhances what you can do in a pivot table. Traditional pivot tables, on the product team, we often refer to them as native pivot tables, generally work against a single flattened table, right? How many people in the room use pivot tables? Wonderful. I love seeing all those hands go up. So when you're doing that, I'm sure that for many years you've gotten used to this notion. When I have a transaction table, and then I've got some other, often people refer to them as lookup tables. I've got other auxiliary tables in another place. How many of you use VLOOKUP formulas to go pluck some extra data and add it into the table, specifically so you could create a big flattened table and then use a pivot table against it and have this single field list? Well, what we get now with Power Pivot is I get a database. I get multiple tables with relationships between the tables. My field list, as you will see, has multiple tables in it, and I can just drag those. I don't have to go do all of those VLOOKUPs to bring the data into a single flattened table, I can just grab the fields from whichever table they're in. I grab some fields from the sales transactions, grab something from a product table, grab something from a customer table, grab something from a calendar table, and just bring them into the pivot table, and it just works. It's very natural for end users to see, once you've worked with multiple tables in the field list, you sort of wonder, didn't it always do that? You know, it sort of feels that way. It's really, really very natural. And this eliminates pulling in all these replicated copies of data. The other thing I'll mention here about the data model itself is that it's got very good compression. Part of how it does that is each value is stored in that data model only once. So if I were loading up a phone book of addresses, let's say, you know, and somebody's name is Smith, we'll say Smith will be stored once, along with a little notation that there are 11,000 of them in there, you know. And so we don't repeat everything over and over again, and so we get really good compression. It's one of the big advantages of having a column-based store as opposed to a row-based storage system. So with that, I'm going to go to, click there, and this should bring up, good. So here I have my Excel workbook, and if I go to my Power Pivot ribbon here and click Manage, that brings up this other window. This Power Pivot window, I just want to point out that these two windows, these are all running inside the Excel process. So it's one program that's running. We just have multiple windows, one for the Excel worksheets, and this other window for the data model. And this data model, this is the diagram view of the data model. You'll see up here in the ribbon, I can switch between data view and diagram view. And in this particular data model, this is a completely trivial and phony database that I created by hand. I've got a few customers, each customer only very little data in it, but it demonstrates the point. I have sales transactions in the table down at the bottom, and these lines show relationships. If I click on this line, it shows that I have a many-to-one relationship. The customer ID in the sales transaction maps to the customer ID in customers. Similarly, you know, the product ID here, if I click on this line, product ID in the product table maps to the product ID in the sales table, and similarly the date maps to the calendar table. If I switch back to the data view, I can see that I have this grid view where each tab here is a table. All right, and as you can see, for example, I have 5 customers. I've just got a customer ID, name, so on, a product table, and okay. Now, let's go into the sales table. Here are my sales transactions. There are only 50 transactions here. The table that I brought in only had these first 7 columns. So I've got transaction ID, date, customer ID, product ID, a quantity, a price, and a discount percent. Then I've got a couple of additional columns here, which are calculated columns. They have a formula associated with them. The formula language that we use in the data model is called DAX. This DAX language has exactly the same syntax as Excel formulas, but the functions that are available are slightly different. We have many functions that are available both in Excel and DAX, but there are some additional ones here that will do other things. In this case, the formula for amount just multiplies the price times the quantity times 1 minus the discount. And so you see how that's operating. Down here in this bottom area, this is the calculation area. You'll see there's a ribbon button here. I can turn that area on and off. And I have a slider, so I can, you know, make this bigger or smaller as a proportion of my screen. I think I just accidentally scrolled something down. The grab bar small. Okay. And if I look here, these measures, think of a measure as a formula with a name. So this is transactions is the name, and the formula is count rows in the sales table. It's very, very simple. Normally you don't want to think of a measure as having a value, because a measure has many values. When I drag that measure into a pivot table, if my pivot table happens to have 20 things down the left and 10 things across the top, I'm going to get 200 different values for that measure, each one in a different context, right? So I'll get, if I had countries down the left and years across the top, I'll get a separate value for each intersection. So the measure is something that's going to be evaluated for some portion or some slice of the data. And in here, I can see, for example, there are 50 transactions. That's what the count tells me. But if I were to come up in here and filter, for just some of the products. Like I'll hit this drop down and say, oh, I don't want products 1 or 3 or 4. I'll just keep 2 and 5. But when I do that, now you'll see that the transaction says there are 18 transactions for that selection of products. So I can filter, but this, I can filter it, and this will tell me the value of the measure in this display context, but what I'll get in a pivot table will depend on the layout of that pivot table. Okay, so now if I go to the Excel window, I'll click up in here and go move over to the Excel window. And let me go to I'll pick a pivot table here. Just to show you the field list. You're all pivot table users, so you'll find this interesting. By the way, by default, this comes up normally looking like this. I have the fields, and underneath I have these wells where I can drag values, right? I have the row area, the column area, and the values area. I like to make this thing nice and wide, and then I like to change the default to look this way, because I think it's then easier to see everything. You'll notice here that I do have these multiple tables. The active one, in this pivot table, the fields I'm using are in these tables, but if I go to the All tab, so I have the active or all, if I go to the All tab, there are more tables show up here. And I can expand these and use whatever fields I want from the various tables. I don't have to consolidate them into that single flattened table at all. Also, I would point out that here the icon on these first 4 tables has a slightly different look than the last 2. These first 4 tables are tables that are in the data model. These bottom tables here, test 1 and test 2, are just tables that I have on my worksheet grid. If I go over here to my test ribbon, you'll see I have here a test 1 and a test 2. And these are not yet in the data model, although we're gonna demonstrate putting them there. So that shows you a little bit about what this looks like here. I know that sometimes it can feel like, because they're separate windows, like they're separate apps, but really Power Pivot technically is an add-in inside Excel that we ship with the product. Okay, let's go back to so let's say that I want to import data from the worksheet and I want to bring it into the data model. There are definitely a couple of different ways that we can do this. And I can bring data from virtually anywhere. I can bring data in from a SQL database or an Oracle database. I can bring them in from files, from other workbooks, from this workbook, from web services. And generally, it'll be brought in again whenever I refresh those connections. So if I go into my data model and I say, I want to refresh certain tables, or if I go to a pivot table and hit refresh there, we'll bring the data in again. We do have a couple of different ways to do this. So there's one option in the Power Pivot ribbon called Add to Data Model, which just does a really fast, takes the data in their sheet and just adds it to the model. And it's just really, really fast and really simple, and you don't need to use any kind of a complicated editor. But then there are the times when you really want to do something you want to do something more complicated. You want to cleanse the data, you want to manipulate the data, you want to transform the data in some way, and we're going to see that as well. And then we use what we refer to in Excel 2016 as get and transform. In Excel the get and transform capability is in the data ribbon, baked into Excel 2016. In 2013, it was a separate add-in called Power Query. So you'll hear lots of people talk about Power Query. The same Power Query technology built by the group we refer to as the Power Query team within Microsoft is just part of Excel. We started out calling it Power Query in Excel, and now we've just made it an integrated part of the product because there are already enough things with the word power in front of it to confuse people from one thing to the next. So now it's just getting data, right, in Excel, in the Excel world. But that Power Query tool, which I'll show you as well, also is used in Power BI. Just as we have the same database engine, a tool for fetching data and transforming it and loading it into the engine is, again, the same underlying technology and the same tools, whether you're doing stuff in Power BI or in Excel. And so let's take a look at those. Get that to the right place. Okay. So first of all, I'm going to go to that test. I'll click up here, go back to my Excel worksheets. Go to the test worksheet. Here is a very small table that is named test 1. And what I'm going to do is I'm just going to go to the Power Pivot ribbon. Actually, what I will do is I'm going to put this on the left, and I'm going to put my power pivot on the right side of the screen and hope that the resolution is such that you can all see it. There we go. Okay. And clicking in here, I'm just going to say Add to Data Model. I press the button, and like magic, over here, another table gets added to the data model. It's called Test 1. You can see the Test 1 tab at the bottom, and the values are there. And I'll come over here into the data, and now I'm going to change some values. I'm going to say, you know what, actually now I want this to be, you're going to have some numbers like 1111, 2222, 3333. All right, I've changed a bunch of those values to be 4 digits. I'm now going to come over here, and this happens to be a linked table, and you'll notice that it's updated automatically in the data model. So that's very clean, very simple, very, very easy way to do it. But not all that sophisticated. Let's look for a moment here at test 2, this other table. Test 2, I'm going to expand this here, it looks sort of like a pivot table already, right? It's this, the data is laid out month by month. I've got fiscal year down the left, I've got month across the top. And in this form, it's hard to do pivot table stuff with that. So what I'm going to do here is I'm going to use the get and transform capability, formerly known as Power Query in Excel, and I'll go to the data ribbon, and I'm going to say, get data from this table. And when I do this, what comes up is my query editor, right? This is the query editor. There are a bunch of things you can control in the view. I happen to be showing a formula bar here, but I could turn that off, depends what I want to see. And it shows me, well, you've got this thing, and I'm going to maximize this so you can see it all. I've got these 12 columns. That's not really what I want. What I want to do is I'm going to pick these 12 columns, and I'm going to want to transform that, and I'm going to say unpivot those columns. Now I have the fiscal year down the left. I'm going to rename this attribute. I'm going to rename this one to be month. Where's my? Oh, I had more than one column selected. Sorry, now I will rename that. We'll call that month. And we'll call this amount. And I could say, you know, I actually want to format that. That's amount. And I'd like to format that at, oh, it's not in transform. I want to do it here. We'll make that a currency. And now I have data in a form where I could do a pivot table. This is way more usable as a data source for pivoting and so on, because I can do a lot of manipulation here. And then I get to decide with every query whether the data is coming from an external database or it's coming from within the workbook or wherever it's coming from. There are some options. I can say, where do I want to land the results of this? Where do I want the data to wind up? And I can bring up a dialog here and says, well, do I want the results to land in a table, on a worksheet? Do I want a pivot table report based on this? Or I can, in this case, I only want to create a connection and then add it to the data model. So now when I do this, I say, OK, what'll happen is it creates a query for me called test2. It runs that query. It brings the data over here into my model. Let me maximize that to show you. And sure enough, now I have a table in my data model called test2. OK, so that shows that transformation. There's an amazing amount of stuff that you can do there, and I know that at this conference there are a bunch of sessions on this Power Query technology specifically, talk about all the kinds of things you can do. But often when you're bringing data in or working, particularly if you're working with data that started in a spreadsheet, it needs some cleansing, right? It needs some, there's some duplicates you want to remove, there's some blanks or bad values you want to take out, and all of that can be done as part of this moving the data from its source into the data model. Then you wind up with cleansed data. So that's a very powerful aspect of this. Oh, I was not, hit the wrong button in the wrong order. Okay, DAX formulas. So the DAX formula language, again, is used in analysis services, tabular models. It's used in whether they are on analysis services servers, It's used in analysis services tabular models when they're part of Power BI desktop or when they're part of the powerbi.com service. So again, the same language because it's the same database engine used in all of these places. We designed the DAX formula language. We made it look exactly like Excel from a syntax perspective. There are a couple of enhancements. There are some functions that do things that you can't do in Excel formulas because there are some things that Excel just never do anything about. For example, Excel never had in the past this notion of having, it had tables, but you couldn't have two tables with a relationship between them. So we had no need to have functions that worked on the relationships because that didn't exist. So we've added that to DAX. Another example is that we have functions that return in Excel, since all formulas are designed to return a value to a cell in a worksheet, the result is always a scalar value. But with DAX, we have functions that return entire tables. And then we have other functions which take entire tables and perform manipulations on them. So for example, I can get an entire table, and then I could say, okay, for this table, which was the result of that formula, now I want to go through and add up the numbers in the third column and divide it by the sum of the fifth column, or things of that nature. So I can do a lot of manipulations on entire tables. And we use these formulas for calculated columns. We use them for measures. And it's also a query language. So for those who are familiar with multi-dimensional OLAP cubes, that used a language called MDX, which I think is a little more difficult to use than DAX. But now what we have is DAX here, and you can send queries using either DAX or MDX to the database, and they'll work. Excel pivot tables, by the way, happen to send MDX queries because they always have. You could always connect pivot tables to multi-dimensional cubes, so we kept that infrastructure, and those queries work also against tabular models. So these are the three places where the language is used. All right, switching machines. Okay, so going in here to the sales table. Here's a couple of examples of the calculated columns. Here with the sales table, I brought in from the source, we brought in these first columns, and then I got two additional calculated columns. We have these measures down here, transactions and sales. This looks an awful lot like the sum function in Excel. You see it's sum of sales amount. The syntax that we use here is this is the sales table, the amount column in the sales table, and we're simply adding it up. But again, there are some new formulas that work in here. If I go to the products table for some additional examples, we've got here product sales. So here's the example. This is a function that's very similar to VLOOKUP, but in the reverse direction. So here, what I've done here, as I've said, for a given product, I want to go and get the related table. I just bring back an entire set of rows. Give me the related table of rows from the sales table, and the value I want from each row is I want the sales amount, all right? And so I want this measure evaluated on that table. So this, I want the sum. It's the sum x of the amount column in the sales table. So by putting this in the product table, I get this is the sum of the sales for product 1, this is the sum of the sales for product 2, and so on. And so it's like a VLOOKUP, but I'm bringing back a whole set of rows and then adding them up, right? We're going to spend some time in a moment talking some more about sales rank. Let me not talk about that just yet. For simple measures, we have, let me keep going. I think I've mentioned the measure thing I wanted to show you. Okay. Okay. Let's talk about calendars for a moment. Many people, one of the things we have in DAX is we have a lot of functions that know about something we call time intelligence. You can imagine wanting to, frequently people want to do reports and analysis where you compare one time period to another. I want to compare this period to the same period last year, the same period last month. If my dates are February 1 to February 10, last month is probably January 1 to January 10. But we do a bunch of special things so that we can, because if my dates are February 1 to February 28th, I may not want to compare that to January 1 to January 28th. I may want to say, recognize, hey, I have a full month here and I want to compare that to a full month. What's more, many people have data where they don't use the standard calendar or standard months. They use 12 30-day periods, or they use a 4-4-5 calendar, and the calendar they want to use for analysis is different. So we think that we have a lot of functions that require you somewhere in the model to have your calendar, to have a list of dates. The rule is that the dates are contiguous. You don't have any date in that column twice, and you don't have any missing dates. And we use it to automatically do some of these date calculations. And all of a sudden, things that used to be hard seem really, really easy because we have DAX functions to do that. You can build custom calendars really any way you want and account for them any way you want. So I have an example of that I've done here in Excel, where I built a simple custom calendar that's actually split in 4-4-5 periods. And let's take a quick look at that. So here is my calendar table I built. I've just built a table here. It's got, hang on one second. Okay. It's got just the dates, just a list of dates. In this data set, I've just got the list of dates for 2015 and 2016 going down. For each date, I know what the day of the week is. I've assigned a week number because for my calculations here, I want to know on every week to have a unique week number. I've defined the quarter. You'll notice here that this quarter starts on Sunday, January 4th. It was important for me in this calendar to start on the Sunday of that week. I've got a column calculating the week in the quarter, what is the month in the quarter, the fiscal month number, and I've got a comment on some of the dates are, is this a weekend, is this a holiday, and I could customize this really any way that I want. What this allows me to do is it allows me to go and build, I can then use these columns in a regular pivot table to do a bunch of very simple things. For example, I can come in here and say, let me just get some of this out of the way, make it easier. So for example, here I've got within my fiscal year, I've got the quarters, they've got and months. I can come in here to month 7 and say, what are the dates in that month? I've got measures to measure what are the days when I'm open, what are the days that are weekends, what are the holidays. I can do a number of things like this. And this is done using measures, and the measures are really quite simple. Going back to my window here. The days, count of days is just count rows, count the rows in the calendar table. The days that I'm open is count the rows, filter the calendar table, where the comment column is blank, and just count those. So if I've got any comment in here, I assume I'm not open. In the comment, I'd put in Y. I'd say, okay, count that where the word holiday appears in the comment column. Count where the word weekend appears in the column. So I've just built these measures, days, days open, holidays, and weekends. So when I come to my pivot table, I have in the calendar, in my field list, these measures for the days open, the holidays, the weekends, the days is available to me, and I can just use it. You'll see here that this is 4-4-5 because the count of days in the months, it goes 28, 28, 35, 28, 28, 35. And, and if I want to see, gee, why are there 3 holidays in month 5 of Q2? What's that? Well, sure enough, there it is. It's November, and my 3 holidays, if I take a look, are November 11th, Veterans Day, and then I've got 2 days down here for Thanksgiving that year, right? So it's just a very straightforward calendar, but by putting this in, this allows me to do some very interesting things like, we've got, so now I've got my sales. I can do it by fiscal month and quarter. I put the sales measure on a pivot table, and now I'm getting comparisons of comparable periods. Again, this is some phony small amounts of data, so the numbers don't align closely. But it makes it very easy to do this sort of thing because I want to compare, the April of this year to April of the previous year, and we're able to do that. Okay, and so let's go to. We'll switch back. Yes. the question is, if you don't have a calendar table, will the measures not work? There are a set of functions in DAX. If you use those functions, they will be looking, one of the arguments to those functions is the name of the column that contains a consecutive set of dates. So those functions need that, but otherwise everything will just work. But it is a good practice to have a calendar. For people who did multidimensional stuff, it's often referred to as a time dimension or a timetable. Okay, all right, measures. This is the heart of it. So measures, as I mentioned, are named formulas. When a measure is done correctly, it should be possible to take a measure and have that measure be evaluated for any slice of the data. I want to my goal is to write the formula in such a way that I can take that measure and apply it to an empty data set, a data model with no data, the entire data model, half of the data model, 2 rows from the data, it doesn't matter. However I slice it, if I slice it for 1 month, 1 country, 1 product group, one whatever, you want their measure to deliberately return something. That something might be a blank, it might be a 0, but you want it to return something so that the measure, when you drag it into a pivot table, it will work for all rows and all columns. That's the idea. The best measures are usually just simple aggregations or combinations of simple aggregations. So it might be the sum of a sales quantity, or it might be the sum of one quantity of one column divided by the sum of another, or the difference between 2 sums, or things of that nature, as opposed to a formula that assumes where you've written it in such a way that it can only possibly work if the pivot table starts out with products down the left and days of the week across the top. And in any other context, it would blow up. So you want to keep measures simple. And it turns out that by keeping them simple, you can do some very, very powerful things, and the measures can build on each other. I do want to call out the difference between what we call implicit measures and explicit measures. An implicit measure is what you get when you drag a column into the pivot table, the values area. Normally, if it's numeric, you'll get a sum. If it's text, you'll get a count. That's kind of, it just does that. And there is a value field settings thing that you can go to and change it from count to sum to min to max to average. There are 8 or 10 preset aggregations you can pick. That's different from a DAX formula where you actually write the formula and where you can do much more powerful and much more complete and complex things. And so we just call those simple ones. We've just dragged the column in an implicit measure, and then the explicit DAX measure is where you write a formula. Remember that a measure will always generate multiple results simultaneously. If there's any one message I really want to convey that I want you to take away from here, it's that measures are evaluated dynamically, on the fly, whereas calc columns, the single most common mistake of everybody who's learning this technology and using it for the first time and playing with it is because, and it's a very natural mistake, it's one everybody does this. Calculated columns seem really, really easy and really, really natural. It makes sense. I put a formula and it fills the column with the results of that formula, and I understand that because it's just like the Excel I've used for the last 30 years, and it just works. So I want to use that all the time because I get it. And in the same way, how many people here know somebody who, when they hear the term pivot table, they get a little bit afraid. They say, gee, I've heard of pivot tables, but that's kind of advanced. I'm not going to go play with that. I'll just do what I'm doing, right? You all know lots of people like that. In the same way, people who are new to this say, oh, measures seems a little complicated. I run into people all the time who have a table, and they filter the table, and they have a total row in the bottom, and they copy the total row and paste it somewhere else. And then they change the filters, and they copy the new total row, paste it somewhere else, and they do it again. And then when you show them that this is just a pivot table, you just get all those answers immediately. They go, really? I had no idea, right? Similar thing happens here. You can do a lot in columns, and there are things that belong in calculated columns. Please understand, if I've got a row and it's got a quantity and a price, and now I want to do a dollar amount that's the quantity times the price, and all the components of that calculation are from within the same row, calculated column is perfect for that, right? But when I want things to be evaluated dynamically, so a great example would be the sales rank. We're going to see that here in a moment. There are some data, some calculations, where if I calculate it up front and leave it static, and then slice the data to a different year, to a different product group, to a different range, to whatever, the numbers I'm looking at just will not be correct. And so I think, I just want to call out, the calculated columns recalculate when you refresh the table. When I load in new data, the columns will all get recalculated automatically. They are dynamic in that sense. But when I have something in a pivot table, and I add more things to the pivot table, and I make the pivot table bigger or smaller, switch things around, the calculated columns do not get recalculated, but measures always will. So measures is really what you want to be using. And we're going to have some examples here of that. And this talks exactly about that, the calculated, yeah. So I don't know if you try, like, if you've ever tried, you have a column, and in that column you've calculated a ratio. You know, you've got a percentage of something. Well, you can't add those up. You can't just take that column, bring it into your pivot table. You'll get the sum of these ratios, and it's absolutely not what you want, right? So let's take I believe the next step here is a demo of some measures. So let's take a look at this. Going to the product table. I have to remember to keep switching. Okay. Going to the, I'll go to my data model. I'll go into the products table. You'll see here that we have a sales rank here. I just used index. We have a rank function. We have a rank X function. It says rank over the products, rank by product sales. And sure enough, based on these numbers, this ranking is right. All right, if I sort product sales in from largest to smallest, the ranks come up 1, 2, 3, 4, 5. But this is not a column I'll want to go use in a pivot table. It's not doing the right thing. Instead, what I really want, you'll see down here, I have a measure called product rank. And what this says, it says, if I'm in a context, I'm somewhere in a pivot table where one of the products has been specified. That's what I mean by if has one value of product ID. If I've got one product, what I want to do is I want to rank the sales against all the products. The rank X, rank that against all the other products, and do that dynamically. And sure enough, if I go back to my workbook, and I'll go to some sales pivots. Here, for example, here's this pivot table where that rank, that looks great, right? Until I start doing things like bringing in other fields. So I'm going to go to my calendar. I'm going to take the year. I'm going to add it to, well, let's add it to the rows right here. What happens is I'm just getting these same values whether they're right or not, right? They're not going to be, oh, wait, I'm sorry, is this which measure? Did I use the measure or did I use the, oh, is this one where I didn't use the, okay. I'm sorry, this is using, let me double check it. Yeah, this one's called product rank. So by using this one, it did work. So the product rank is recalculating. Here, product 3 is number 1. Here, product 4 is number 1. Here, product 3 is number 1. It depends on, it's done dynamically on the fly. If I had not used the product rank measure, if I take that off and instead I use from within the products table, this sales rank column, I get this sum of the, I get this wacky thing that's a sum. It's not what I wanted at all. And so really, I'm just saying, when you have things like, right, here's another example. Here is a per unit discount as a column. This is also in the products table. And if we look at that, well, let's see. That one is, okay. Sorry, it's a measure from my sales table. It's on the products. So here I have a per unit discount measure, which tells me, give me the sum of all of the sales amounts. This says take the sum over the sales table. So for everything in my sales table, take the price times the quantity times the discount percentage, and then I divide by the sum of the quantity. So this is a measure that dynamically will calculate for any slice of my sales data. Give me the total of all the dollars minus the, give me the total of all the discounts divided by the quantity to get the per unit value. There's also a column in here in my transact, which is the discount per unit, right? Which was, but that's not going to give me the, I don't want to take an average of that column. I won't get the right results at all. right? It's, again, a really good example of that. If I go back to my thing here. So this is the measure, whereas if I go in here to my sales table and take the discount per unit, and I'll get the sum of the discount per unit, I get this other weird thing where it starts adding them up. That's not what I want. So whenever you've got ratios, whenever you've got percentages, things like that, you really want to use the measure. Now here's a really good example of some different things that you can do very, very simply. Here, I have 4 different pivot tables. The first one on the top shows sales numbers, just the sales dollars. I've got customer down the left, I've got product color across the top, and these are just the sales dollars. And so Diana bought some black, green, and red. Howie bought red, white, and yellow, and we've got the dollar amounts here. What I did is I've written some very simple DAX formulas for measures to show, I want to show percentage of different parents here along these axes. So here, for example, I've said, show me the sales in the current context, the sales for this intersection, for this customer and this color, divided by the sales for all the customers, but for all the customers. And what you'll see is that I'm really saying here, give me things so they add up to 100% in this direction, going down. So Diana's 13,000 as a percentage of the 40,000 down below. Because this one down below, this is the sales for all the customers of black product. I didn't change the color, I just changed the customer. I went from one customer to all on the denominator. So the numerator is the sales for this cell, the denominator is for all customers, and that gives me the second pivot table. The third pivot table, I did something very similar, but here I said, give me the sales for my selection in the pivot table, divided by the sales where everything, the coordinates are the same, except not just for this product, but for all products. So these add up to 100% across to the right. So you'll see that Diana's sales, this is the percentage of black, green, and red as a percentage of all of Diana's sales, right? Or I could say, give me the percentages as a percentage of the grand total. So here I've said, give me the sales for the current cell divided by the sales in the grand total bucket for everything across all of it. And so these percentages, it's my hope that if I select them all, that they'll add up to the, without the totals there, they add up to 100%, the whole darkened area that I've got there. So I can really manipulate this thing any way I want. It's fairly simple. I just have to start thinking in terms of what is my pivot table going to look like and what manipulation do I want, because I wrote one formula, just one simple formula. I dragged it in once and it just worked across, and this pivot table could have been much larger, could have had many more things on it, could have been sliced, and in fact we can certainly do that. I can come in here and say I want to do this based on I'm going to put, you get to pick anything here. I'll pick some calendar thing, and I will take the calendar year and I'll add it. Oh, let's say, where is it? Fiscal year. I'm going to add it to my, let's see, add it to my rows. There you go. So now I've just changed this. Again, I've got everything as a percentage of grand totals, but I've got them split by year. And again, as you know, pivot tables are so incredibly powerful. I can group it by year and then by customer. I can reorganize this any way I want. The power of the measure is that the measure will still work no matter what I put on that pivot table, no matter how I slice it, no matter how I shape it. It'll just work and do that stuff. So it becomes very, very powerful for this sort of analytics. Okay. So the measures are stored. The question was, where are all those measures stored? The measures are stored with the data model. The data model, this database, contains tables. The tables have columns, and they also can have calculated columns. There are relationships in there, and there are measures. And the measures are actually tied to, they're stored with the table at which they're named. They have a table, because that determines where they show up in the field list. But measures have globally unique names, so I can move a measure from any table to any other. But they're stored in that database within the data model. Okay. So just to review, so what you've seen here, and we're basically at the end here, what we've seen is that we have a data model with multiple tables and relationships between them. We can import data. I can go add to data model and bring it over into the model very, very quickly with no fuss and no need to use that query editor. Or I can use this powerful query editor, and we happen to do unpivoting, but you can do all kinds of transformations and data cleansing. DAX is the formula language. It looks a lot like Excel formulas, but there are some different functions that you have to learn. We can accommodate custom calendars. You can do calendars any way you want. It's just a matter of setting up the calendar as a table, and this notion of measures. And really, if you only remember one thing, remember that calculated columns are really easy, and you're going to be really tempted to just use those and skip measures. But measures are really what you want if you want really dynamic calculations that get done on the fly as you slice and dice your pivot tables. And with that, I'll just say we've got some slide now. The deck and the sample workbook, all of this is going to be made available to you. I've been assured. There are a bunch of resources here for Excel. We've got a bunch of sessions for those who are big Excel users. Here are just some of the sessions today and tomorrow. We've got 2 days of sessions related to using BI within Excel. They didn't put the location where into this slide, but anyway, we'll be possible to get all the stuff from all of the sessions. I've been assured of that. And this is my email address. Feel free to contact me, send me questions, anything. I'm happy to talk about this stuff. I've been working on this stuff for a long time. I get questions all the time. Happy to do it. So you can reach out to me directly, howied@microsoft.com. And we've got the slide. We'd love for everybody to fill out session evaluations. And I guess I can take additional questions. And if you could either come to the mic or I'll repeat either that or I'll repeat it. I don't know. It's whatever works best.
So in your example where you rank.
Yep.
So in your example where you ranked your products within the month, you had the ranking of say 1 to 5, but that was contained within the month. Could you rank them all? So per month, per product?
Yes,
as well?
there's a lot of different, there's some very powerful rank functions in the language. You can do rankings basically by anything. And I was just showing sort of a simple example here that did a rank based on the sales number against the product table. I got 5 numbers because I only had 5 products in the product table. But yes, you could do that.
In one of your pivot tables,
yes,
the grand total didn't total 100%.
Hmm? What?
The grand total
Yeah.
didn't sum 100%. Why is that?
Did not, one of the...
You show like 4 pivot tables.
Okay, this one, when I scroll up.
Can you show us?
What, this one?
I can see it.
Hmm? Oh, I'm sorry. Right, I have to hit the magic switch button here. Okay, these 4? Which one? This, okay, so you're talking about the third one? So this one, these, in the third one, I've said it's across the products. So these add up to 100%. These totals down here add up to 100% on the right. The right column is 100% all the way down. So you'll notice on the second pivot table in this display, that's 100% coming down. In the third pivot table, the 100% is going to the right. Those are all 100% down the right-hand side. And in the fourth one, it's just as a percentage of the grand total. Yes, sir. So the question is why I didn't use the word calculate. So I'm just happy to be showing here, searching. There is a shorthand syntax supported by the DAX parser. If you're using a calculate function, and if the expression in the calculate function is just the name of a measure. So if I have calculate measure name, comma, filter, 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 you can write that exact same formula as measure name, as if it were a function, open paren, filter, filter, filter. So measure of filters is identical. It's just shorthand syntactic sugar, if you will, for calculate the measure, comma, the filters. And I did that because it's easy to sort of follow along when I'm describing it here. Sales divided by the sales for all products. But it was, under the covers, that is calculate.
But it's confusing.
I know, yeah. New stuff is always confusing. All right, I think I'm happy to stick around, and I'm going to be at Ask the Experts as well. And I'm happy to keep talking, but I know they want to set up the room. Thank you.